All right, it's my pleasure to introduce our speaker tonight, Bob King, who will be presenting over Zoom. And Bob is an author and educator. He's also a writer for Sky Telescope, local magazine, and the website. And he's also written a book called The Magnificent Aurora. He's also an AAVSO member. I know we have several of our clubs. Share some stories there. So without further ado, I'll hand it over to Bob, and we'll go from there. Are we gonna?
He'll take over.
Okay.
All right, well, pardon me, thank you very much. It's a little echoey for me, but I caught your drift, so I really appreciate your introduction, and it's a pleasure to be here tonight and an honor to be here as well. I very much appreciate the invitation. I thought I heard the word Aurora that you mentioned, and I was tapping away here momentarily before the beginning of the meeting because we have a really good shot at seeing the northern lights tonight. Everything is lining up just right as far as the blast coming in. And I don't know if you're going to see it as far south as Texas, but certainly here in the upper Midwest, we should have some Aurora Borealis by the time it gets dark. So that's another interest of mine. I'm a visual observer primarily. I take wide field photographs, and especially the northern lights. And I now use a sea star on occasion, which I'm sure a few of you guys do as well. But most of the time I'm visual. I have a variety of telescopes, and I like to just hunt down and look at all kinds of things in the night sky. And tonight I'm going to talk about some of the things that they all look pretty much the same in the sky. They look like little blips or points of light, but knowing the difference between them, being able to imagine and visualize what you're seeing makes finding them really, really exciting and very fulfilling too. So with that, I'll start in. And if you do have questions, I'm not sure what your format is. If you want to jump in with a question, you can do that. Just somebody flag me and let me know. Otherwise, we can wait to the end of the meeting. First of all, can everybody hear me okay? I should have asked that in the beginning. All good? Thank you, David. Yes. Then we'll go to the presentation. And I have given this just once before.
You can see
it was to the AAVSO, the American Association of Variable Star Observers. I've been a member since 1982. And because it's about variable stars, I'm not sure how many variable stars you have in your group. I know that there's at least a few, but I was never a variable star observer until suddenly I was, and I had kind of a funny reason for becoming one. And then they grew on me. So it's called Things I Thought I'd Never See, but by gosh, I'm still eager to see things I've never seen, including maybe some of you have been tracking Venus in the morning sky. It was visible, and it's still visible now in the morning, at least in northern latitudes, as a morning star, even though it's still officially an evening star, which is kind of fun. Probably like some of you, I started out with just the most basic variable stars. Algol, right? The demon star in the constellation of Perseus. Here it is. It's at maximum here, and then at minimum on the right. Every 2.9 days, it fluctuates. It drops from maximum down to minimum, and then light recovers, and then 2.9 days later, it happens again. It's just a little light changing in brightness. Interesting enough. And then you realize what you're actually observing is an eclipse of a star that's 93 light years away. There's actually a pair of stars, as you can see here. Here's the light curve showing the dip as the larger, fainter star orbits in front of the more compact, brighter star. So you're actually witnessing an eclipse, even though it looks like a very one-dimensional happening. There's very much a three-dimensional universal thing happening out in front of your eyes. Another very famous, very well-known variable star that I'm sure a bunch of you have seen is Mira in the constellation of Cetus. And Mira is the wonderful star. Its name means wonderful because it does wonderful things. It goes from being quite faint, around 10.5 magnitude, all the way as bright as, it can become as bright as the North Star, Polaris, so about second magnitude. And this time, there's actually a physical change that happens in the star, unlike Algol, where you just have two stars orbiting around their common center of gravity. This star is physically changing its shape and temperature. It's expanding and contracting or pulsating. And that expansion pulsating period takes 331 days to go from fully bloated back to compact to fully bloated again. And this just to give you an idea of what Myra looks like. If you could get up close to it, you would see it expand and fade, and then it would contract. And during the contraction phase, right about there, it becomes its brightest. That heat is trapped, and then the heat is released, the star expands. Myra's in this sort of unstable state, very late in its evolution, and it's not able to just keep the same diameter like the sun. It does not have that stability. It overshoots itself, gets small, comes back again. So we can see these pulsations, these kind of wonderful things happening with our eye as a change in Myra's brightness over time, over many months' time. So again, you're going to see a number of illustrations and animations in my presentation, and they're meant for a very important reason so that it helps us visualize what we're looking at. As amateurs, a lot of the things we see in our telescopes are kind of on the faint side. So any knowledge that we can bring to them really helps illuminate what we're seeing. So I just observed a few variables, and then sometime in the late 1970s, early 80s, I read this wonderful book called Starlight Nights by Leslie Peltier, Ohio amateur astronomer. And it is just lyrically beautifully written, simply written about how the joys of being an amateur astronomer and discovering the wonder of variable stars. And so I started to, kind of scratch my chin thinking, boy, maybe I should become more involved in looking at these variable stars, because prior to that, I've been doing mostly planets in my telescope, the moon, and especially deep sky objects, all wonderful areas of study. So this is a picture of me there on the left. During the time exposure, I ran in, so I'm ghostly. But I wanted to get a bigger telescope. This is back in the mid-1980s, and it was time, I thought, to I was in a dark place. I'd moved to where I'm at now in Duluth, and I thought, wow, let's take advantage of these dark skies. And this local camera store had a C11, a Celestron 11 SCT, and I lusted after that for I don't know how long. And finally, I saved up the money, a ridiculous amount of money, and I bought it. But I promised myself that I would not just buy it to look at deep sky objects. I felt I had to have a purpose in a sense. And I decided that would be to make some small contribution to science through the observation of variable stars. So I hooked up with the AAVSO and I started getting their star charts. Back in the old days, you had to send them a letter and request the charts, and you would get something like this right here. Here's a very well-known variable. It's called R Leonis or R Leo. The variable here is marked by an open circle. These are stars that you use that are near the variable as comparison stars, because the goal with variable stars is to determine how bright they are. Remember, we're always talking about stars that are changing continually somehow in brightness. And so you're trying to pin it down at various times during its cycle. And sometimes scientists can use that information and find out all kinds of wonderful things, period changes, flares, outbursts, and so on. So you just estimate the star's brightness by comparing it with nearby stars on the map. So let's say the star was magnitude a little bit fainter than 5.7, but a little brighter than 6.4. I would look at that and go, okay, we're going to call it 6.0. And I'd write that down and I'd send that in. Nowadays, it's really great. The AAVSO, you don't have to be a member, or you can kind of be an associate member where you're not paying dues yet. You can go to this website, aavso.org. You can put the name of the star in and just click a button and say, plot a light curve, in case you want to see what it's been doing. Check recent observations. Let's say you've observed it. You want to kind of see if you're in the ballpark, especially if you're a beginning observer. And then you can create your own finder charts right there on the spot. Just print them out. So very wonderful, really easy access. The first thing I discovered about variable stars was how damn hard they were to find. Here I thought, after seeing many obscure deep sky objects, I should have no problem. Wow, it was a lot harder to find a pinpoint of light amongst this jungle of stars. And this is a classic example of EM Cygni. And you're like, how am I ever going to find this star? Um, so over time, and we use these two as observers to locate deep sky objects, we form little figures in the sky. I would guess that one of the most popular ones is the triangle, since they're very easy to make. But I make hexagons and trapezoids and triangles and all kinds of interesting shapes. And these shapes, I can put them on the map, or I'll just sometimes visualize them amongst the stars and memorize the field of view before I get there. And then I can sort of hop. It's almost like being on monkey bars. I can go from bar to bar to bar and then swing my way right down here to that open circle, that variable star, and then make my estimate using the comparison stars nearby. By the way, the comparison stars do not include the decimal, so that's 10.0, 14.1, 10.4, and so on, just to keep the clutter low, right? The irony of it all. There are many different types of variables. You saw Algol, which is an eclipsing variable star. You saw Mira, which is a red giant pulsating variable. But I soon discovered that the types of variables I especially like were the things that blew up. And maybe I can attribute that to when I was a kid. I used to like, setting off firecrackers and things. I don't know. But one of my very first stars that I saw blow up was SS Cygni in the constellation of Cygnus, the Swan. And here it is in its quiet state. You can look at this star 15 nights in a row, and it's going to sit there and look pretty much like that, just a faint field star. And then 24 hours later, you go back, and it's boom, shot up 4 magnitudes. It's in what we call outburst. And SS Cygni is one of a class of stars called dwarf novae, sort of a nova-like star in a way. And in a dwarf nova situation, you have a white dwarf star, and it's surrounded by a disk of dust and gas that's been accreted or pulled away, flowing from a very, very close companion. In the case of SS, it's a red dwarf. So you have this super close companion, red dwarf, white dwarf. The white dwarf is winding up material that it's getting pulled off and flowing from the red dwarf. And that forms a disk around that white dwarf. Eventually, that disk can build up and can overheat. Material from the disk is transferred down to the surface of the star, and that can cause a brightening within the disk. And that is what you see when you see a dwarf nova and outburst. To me, that is just incredible that with the scientific knowledge we have, with the people who have done the research to give us these pictures that we can use, when you look at SS Cygni, you can picture material being transferred from this disk in this very tight relationship between these two stars, or maybe just an extra brightening in the disk as the flow of material increases. So that's the basic dwarf nova model. And keep it in mind because it resembles a lot of other situations involving other cataclysmic or explosive type variable stars. Here's a nice animation that shows you what SS Cygni looks like, flashing back and forth, has an outburst about every 50 days. So if you just put it on your list and you go out and you keep observing, you're going to be rewarded with a wonderful outburst. And it's always exciting to report those outbursts back to the AAVSO. Probably the most famous star right now, we're all waiting for this one to go, right, is T Corboreal, T Corona Borealis. It is right here in this horseshoe-shaped constellation called the Northern Crown. The brightest star in it is second magnitude Alphecca, and not too far away is T. This is a recurrent nova, so it's actually a nova that recurs on a time scale that's not so long that You have to wait 1,000 years for it. In this case, it explodes or goes nova approximately once every 79 or 80 years. Now, there was a prediction last year that this would happen August, September, October, somewhere in that zone, and it never did. So we're still waiting for this to happen. The star is out every night. Most nights it'll be around magnitude 10.1, so easily within the reach of a 3-inch telescope. There have been some recent changes in the accretion rate that indicate that a blast is still imminent. And the accretion rate is just the amount of material or the strength of the flow of the material into that little disk that is swirling about the white dwarf. Let's take a look. We're going to actually, we may never see this, right? We try to make predictions about these recurrent nova, but maybe it'll be 10 more years. Who knows? This though will give you an idea of what does happen during an outburst. If you're ever looking for a good site, for those that have not used it, the NASA visualization site is really wonderful. This is where this comes from. And you can see the white dwarf inside the accretion disk. This is around a red giant star, and enough material is being wound and then funneled down to the surface of this white dwarf that it becomes compacted, heated, and it ignites in a thermonuclear explosion. You get this sudden blast of light. And that is what a nova is. And this explosive blast of light, because of this massive explosion that we're anticipating will happen soon, this should brighten that star from 10th magnitude to about magnitude 2. So it should be equal, pretty much, at least for a night or two, to the brightest star in Corona Borealis, Alphecca. So this is what I do, and this is what I encourage people to do, like when I do community education astronomy classes, is to just take their smartphone, show them where to find Arcturus, how to use Arcturus to drop on down to the little horseshoe of Corona Borealis. And then this was taken last night just from my yard. I held up the phone, did a 10-second handheld exposure, which you can do nowadays with cell phones, and was able to get down to about magnitude 6.5. Now, it's not 10th, but let's just say that night, last night, the star was magnitude 6.0. It would show in this image. So I don't know who's going to be the first person to see this outburst, but I think there's a really great citizen science opportunity asking people to just, randomly just take a picture if it's dark out and you've got your phone and check it now and again. There are some new predictions on eruptions having to do with research on multiples of the period of this double star. Essentially, it's a double star, which is 225 days, which indicate that there's a chance the next prediction for an outburst is coming up really soon here, March the 27th. So next Thursday. So put it on your calendar. Just go out for sure. I'm sure we'll see the star exploding on March 27th. If you want to frame grab this, go ahead. I put the paper here that you can read that will go into more depth about that right in the bottom. That's a recurrent nova, but more familiar, and there aren't many recurrent novae known. I think it's just a handful, but there are always nova outbursts. There's like 10 a year roughly in our galaxy that we see, roughly, give or take. Novae occur over a much longer time interval. I've looked it up, and the larger white dwarf stars, it's the same process, but the larger white dwarf stars, you might get an explosion every 30,000 years. So if you see or hear of a nova, then chances are that's going to be it for your lifetime. You'll get to see it once. Some of them take 1 million years between explosive outbursts. My favorite one, though, I've seen many novae over the years. My favorite one was Nova Delphini 2013, which was renamed V339 Del, right there in the constellation of Delphinus. There it is, right up at the top, right there. You can see it. And it really got bright, okay, for a nova. You could see it at magnitude 4.3, so very obvious to the eye. Really a pleasure to see and show people and say, there it is, there's a nova. This is another view of a nova-like or nova explosion. Again, you're looking at a binary system, two close stars, one a white dwarf. In this case, this is a red giant. And we can watch what happens here. Goes around, and it's accumulating material. It's being funneled down to the surface of the white dwarf until finally there's enough stuff that you get a thermonuclear explosion, the pressure, the heat, and so on. And then this expanding cloud of gases and debris that moves out into space. You might not think you can see that expanding cloud at a distance of 5,000 light years, but you kind of can. Here's the light curve of that nova. Over on the left, we have magnitude, starting at 3 at the top, all the way down to 11 at the bottom, and then dates along the horizontal axis here. In the beginning, the star was quite bright, slowly faded, and in this part of its light curve, it was quite red. Maybe some of you saw it and noticed that, oh my gosh, it's changed. It's obviously a red color, and that's from the emission of
What did you say?
okay, in this expanding fire. Pardon me? Was there a question? Oh, there wasn't. Okay. In this expanding fireball, so you get this red color. But if you keep an eye on these novae over time, that shell becomes so expansive and so rarefied that it emits nebular gas-like emissions like a planetary. And you can take an O3 filter and do a blinking thing where you hold it over the nova through the eyepiece, and it'll be brighter looking compared to removing it. So you can do kind of a blink bright, remove, and see it fainter. And you're actually seeing at a distance, one-dimensionally in a sense, but you're seeing that expanding rarefied gas cloud. And that's what I mean about things I never thought I'd see. These are real things, real processes happening in the universe that are accessible to us with a little bit of information and thanks to the help of scientists and illustrators who create these wonderful diagrams and animations. This is the telescope I use now. I still have the C11, it's put away, but I bought a 15-inch Obsession. This is out in the western panhandle of Oklahoma, where I go with friends here from Minnesota every once in a while to take in some really, really dark skies. One of the things you soon learn, besides finding your way through the jungle of stars as a variable star observer, is you learn to methodically expand the ability of your eye to see very faint stars. You've got that chart, right? And you're looking at SS Cygni. At its faintest, it's about 12th magnitude. Other ones, at their faintest, they're about 14 or 15th magnitude. And you think at first, I'm never getting down there. But when you're forced to come up with a number for that star, a brightness, you try to see the faintest possible star. And every time you do that, you stretch your ability and you train your eye to be that much better. As a result of this, with my 15-inch, and even before, it sounds impossible, but I do have some pretty dark skies. With my 11-inch, in certain fields of view, I've been able to see down to about magnitude 16. This is my faint limit right now. It's another wonderful thing about using the AAVSO variable star charts is you can find those and then use them to find out what your own particular limit is. Of course, I'm using high magnification. I'm away from town. It's a really dark night. Well, there's a whole, once you're getting down into the fainter magnitudes, although some supernovae can be bright, like 10th and 11th occasionally, but usually they're in the 14th magnitude range. Once you're down there, there's just so much to see in terms of these exploding stars that are so crucial to spreading and seeding the universe with elements that ultimately regather in clouds of gas and dust that become nebulae, star clusters, and planets. It's like you're watching, after you observe so many of these things, you're almost watching the birth and evolution of the universe, all the essential processes that have led to the formation of planets, complicated beings like us, and all of it, the whole world as we know and love it. So I love watching supernova. This is the Pinwheel Galaxy in Ursa Major, and back in 2023, we had a Type 2 supernova go off in one of the galaxy's spiral arms and remain pretty bright for a long time and very easily visible in the telescope. Maybe some of you caught that. Supernovae are all about getting old, aren't they? Like so many different types of variable stars. They're not stable to the degree the sun is. They're starting to expand and contract, or they're running out of fuel, nuclear fuel in their cores. So this is a typical what we call a main sequence star, living off its life like the sun, nice and stable and happy. The heat and the pressure generated by nuclear fusion in the core is pushing the star away from the core and keeping it from collapsing in on itself, right? If it wasn't for that, the thing would just collapse in upon itself. And we call that the star is in a state of hydrostatic equilibrium. Two beautiful words that sound like poetry to me right now. Unfortunately, in the case of the supernova, uh, which involve the type 2 supernova involves supergiant stars. So you have a star where it can no longer create fusible nuclear fuel in its core. Its final element that it is built up through all of its generations of fusion is iron. And so without the ability to cook up more, the star collapses. So we're going to watch that happen right now. We have our red supergiant here. Back up. Here it goes. So how do we find out about supernovas? Like, how do I know things are happening out there? Well, there's a fellow who lives out east named David Bishop who has a wonderful website. It's called the Latest Supernovae site. You can see the URL right there. By the way, all these URLs, these links, I will have on a separate page at the very end. But he keeps up with all of the latest supernova explosions, and he posts on his page a list of their names, sometimes they're temporary names, current magnitudes, the host galaxy, and so on. And you click on these links and it will take you to more observations and more importantly, it will take you to magnitude estimates and photographs showing these supernovae where they're at in those galaxies. So you can then use that photograph and plot the supernova on a map or just take a look at it on your phone, bring that to the telescope and then track it down. So I'm looking at, this was today, I'm looking at what's out right now. We do have a couple here, which are potentially visible in amateur instruments from dark skies, those that are around 14th magnitude. But check this regularly because you're going to find out. You'll look at that one day and there'll be something at magnitude 11.5 or 12. And you'll be like, I got to get my 6-inch out to see that. So here's an example. When you click on a link, this is a recent one, Supernova 2025 COE. It's in NGC 3277 in Leo Minor, and it's a type 1b. And there it is, a very faint one. Here's the galaxy. There's the supernova. The links will also tell you the exact number of arc seconds to the east or west, north or south of the galaxy. So you can plot your own map if that's what you like to do. I typically plot my own maps. And of course, you'll get the coordinates too if you want to just go with coordinates or go to. Another nice resource to have on hand, and it's free. Some of you, again, may use this, is the Astronomer's Telegram. And you can subscribe to various types of things that you want to look at, whether it's radio, novae, optical, and you just select it and they'll send that to your email box whenever there's something new. This is the place where I get the latest news about T-Corp. It always comes in here if there's some new observation or sudden change in the accretion disk around the white dwarf. So be sure to check the place out too. Of course, there are other types of supernova. We had the big blow there where you have the massive supergiant star collapsing, but there's other types too that involve similar situations as you'd see with a nova, where you have a large star, but then you've got a white dwarf in orbit around it. And those are type 1a supernovas. Those always involve two stars. And we'll see how that evolves. There you have the white dwarf and its disk material that is it's filling up there from the red supergiant. That material is then spiraling down to the surface of the dwarf, and enough of it accumulates to not, in a typical nova, it explodes and the star is fine afterwards. But here, the entire star literally burns like one giant atomic bomb, and the star is gone. And in that burning, explosive burning, it becomes tremendously bright. The reason you can see supernovae, especially type 1, across millions and millions of light years, which is a very exciting thing to see. When I look at a supernova, like any one of these I've made sketches of right here in these galaxies, when I look at a supernova, I just think, has some being in that galaxy seen this? You know, how incredibly bright it must look from their point of view. So it takes me out of the Milky Way and it makes me travel across the universe. And I love traveling. One of the best things about being an amateur astronomer is where we get to go in our imaginations, and for real too, in a sense. So I've been talking about a bunch of kind of fainter things at the moment. So to see these things, there are some techniques, um, many of them, perhaps all of them, you're familiar with, to tease these very faint objects out, especially if they're inside of galaxies, where they're competing with the galactic haze. You know, it's not against a black sky, it's in there in the haze. So the first thing we use is averted vision, right? And instead of looking straight at the object, we play our eye around it, allows the light to reach a more sensitive part of our retina, and you can see the faint star flash in and out of view. Now, if I see it flash in and out of view once, I don't call it an observation. It's a maybe. But if I repeatedly see a star by averted vision, then I'm confident I'm seeing it. A lot of times during the night, you'll wear out one eye. I do. You know, you'll notice your eye gets tired and the averted vision doesn't work so well anymore. So I switch eyes. And I know often we have one dominant eye and one not so much, but by switching eyes, you can really make good use of all your vision. Okay. And you might need it on some nights when like the seeing is perfect and you gotta be out there all night. I often stop and I look away. I'll look up at the sky itself. I'll just completely change my perspective, defocus my eyes in a sense, and come right back to the eyepiece and try again and again and again and again. I'm very demanding on myself and have to be convinced. Have to convince myself that I'm actually seeing something. There's also tapping the telescope, sweeping, which means you're just grabbing the end of the tube and moving a little bit this way, back and forth, sideways. And when you do that, that motion will sometimes trigger your eye to see whatever it is better than if it were just staying put in one spot in the field of view. Refocusing, man, refocus all the time. If you think your focus is great, I'm sure it's fine. Just throw it out of focus. Refocus. It's like a total refresh, reboot on your computer in a sense. Changing magnification makes a huge difference. I used to be timid about that. I would only go up to about 250 or so, you know, based on sky conditions. Now I just go all the way to 400, 450. You know, if that's what it's going to take for me to be able to pull that thing out from the haze, that's what I'm going to do. So I've got some pretty crazy eyepieces. I got a 2.5 millimeter Nagler, which doesn't see a lot of use, but when you need it, need it. Breathing. I take extra breaths. Somewhere I read that if you get oxygenated, you're better off. Don't know if it's true, but I do it anyway. And then I do my what I call mental stacking, which is simply, okay, I see it, I think. I switch my eyes or do something else, look at it again and again and again. It might take a half an hour of again and again and again until in my brain I have stacked all of these images together where I feel confident at what I'm seeing. So those are just some of the things that I do when I'm looking for faint detail. And it doesn't matter. It could be a supernova. It could be coming up with a variable's magnitude, or it could be looking for an H2 knot in a galaxy or some faint detail on a planet. Every one of these things that you do really trains your eye to see everything. It's just a marvelous machine. And when it's not enough, my gosh, you can get your sea star to work for you too. I don't know how many of you guys have sea stars. By the way, pardon my voice. I came down with a really bad cold this week. But often, though, if a new supernova is discovered, sometimes you don't see an image right away, but you can get your own. With the sea star, I have taken pictures of magnitude 16.0 supernova, at least one magnitude 16.0 supernova. So I can look at that photograph and I can use that to inform me better where to look visually. Because as I said, that's primarily what I love doing is visually observing. So this is just an example of a fainter supernova that was in the galaxy 5690. This little scope will do it all. And I'm not talking 2-hour exposures. We're just talking like 20 minutes at the most is all I ever do. Honestly, I've gotten down to 16th magnitude, 20, 25 minutes. I've had some wonderful odysseys in the sky. I thought, well, if I could see a supernovae in these galaxies, maybe there's a chance to see a nova. And we're waiting for a super, let's say in the galaxy M31 Andromeda. But it is close enough so that it does show reasonably bright novae. And sure enough, I hit the jackpot the first time back in 2009. It was discovered, this nova is called 2009 10B. It was discovered at magnitude 17.6. When it rose to 14.6, you better believe I got my Megastar Atlas out, blew up that photograph, pinpointed where that star should be located, and then methodically wormed my way through the Milky Way field stars until I arrived at that nova. And I'm thinking, wow, Andromeda. I mean, it already has globular clusters and stellar associations like our Milky Way, but here it is, something so remote and yet so familiar. It has its own novae, where you have a pair of stars, you've got a red giant, and you've got a little white dwarf. And once again, that familiarity across time and space. This is the page of my journal at the time from October 18th. This is the map that I made from Megastar, plotted the nova's position, wrote it up. There's probably a couple of exclamation points in there somewhere. Another wonderful Odyssey adventure. And again, this is a joy of being an amateur astronomer. Is you get to choose your journeys. You could just decide, I've read about that. I would really like to see that. Maybe I can't see it in my telescope, but if I go to a star party and somebody's really nice and lets me use their 30-inch, then maybe I could see that. My heart's desire. So I went to the Crab Nebula. We all know the Crab, supernova, type 2. We had a supergiant star that blew up here back on July 4th, 1054 AD. There may even be evidence of it in this pictograph from Chaco Culture Natural Historical Park. I went there some years ago. It was one of my favorite astronomical shrines and took some pictures of it where you have what appears to be the crescent, a bright star-like object, and a hand, perhaps the hand of the artist. We don't know. We don't really know exactly what this means, but it's interesting that when the supernova exploded, it was on July 5th in 1054 in the morning sky. The crescent moon was not very far from it on that particular date, right at the time that it exploded. So it's perhaps a representation of that. Nowadays, we know that we've got a neutron star just wildly spinning away, insanely fast at 30. That's the sound of it. Hurting that. Hear it. So, had a perfect night back in 2021. I was at the Minnesota Astronomical Star Party. Pretty dark sky. I had a photograph of the crab. Somebody said, go, take the 30-inch top, go for it. And it was faint. Okay, it was magnitude 16 and a half. So I found a path. Isn't it fun finding your own path to things? It's like going through the forest, figuring out how to get there and then finding some wonderful flower or mushroom at the end. So here it is. There's the pulsar. It's right next to a magnitude 16, approximately 16.0 star, so very faint. And I tracked it down that night, and it was just the faintest light, but I remember thinking, I guess I felt a deeper connection with the humans who must have seen this back in 1054 and were incredibly amazed at it back then. And for me, even though it was just a blip, it was still it. It was what remained after that, that little heart, the core of the star, the collapsed core. So it was quite a thrill to go on this journey. There it is, a representation of the pulsar and the crab. Its beams of radiation, its rapid 33 times a second spin. And why stop at neutron stars? We can go all the way to a black hole, right? The end. And there is a star in Sagittarius, V4641 Sagittarii, where you've got a blue giant star and it's orbiting a more like a stellar mass, a small black hole. The system is normally at magnitude 14. You have to have quite a bit of patience with these. Sometimes you need to look for months. You may not see it this year, but you might see it next year. Well, I was looking at it. This is the layout of the system. Here's our hot B star on the right. We've got a black hole there, 6 times the mass of the sun. You've got, once again, a disk of material that is being pulled off the very closely B star into an accretion disk, swirling around as it goes down the black hole. That material heats up through friction. It's like billions of degrees, and it radiates tremendous amounts of light across the spectrum, including the visible spectrum. So on August 5th, once again, I was looking at it, I was like, oh my gosh, I can see it. It's not 14th magnitude, it's 11.8. Hooray. So it was like watching material go down a black hole in Sagittarius. So very, very exciting. And we're going to power up. We're going to go bigger. Supermassive black holes. Instead of just a half a dozen or a few dozen masses, solar masses, they of course can include millions and even billions worth of solar masses compressed into a very small space, so dense that it will not allow light to escape, and you have a supermassive black hole. And supermassive black holes are what power these very distant quasars in galaxies that are so far away you can't even see the galaxy. All you can see is the flickering of the quasar as material orbiting near it goes down the black hole. So you can witness this through your own telescope by tracking down quasars. So, and a lot of some quasars aren't too faint, but a lot of them are around, like 14 to 15th magnitude. But sometimes when it really takes a big gulp, the supermassive black hole, they can become much brighter. By the way, there are quasars and there are blazars, and it's mostly just perspective. In a quasar, we're seeing it more from the side, and in a blazar, it is pointed towards us, but it's essentially the same thing. So here's a blazar in Cadus Venatici, AAVSO. It's a variable star, no surprise, right? As all quasars are, really far away. It is a lot of fun. I mean, as a beginner, you go out to the Andromeda Galaxy, 2.5 million light years. You're like, wow, this is incredible. I can see that. And as you go deeper and spend more time as an amateur, you kind of keep breaking these distance records. You kind of keep wanting to go further, further. We have an insatiable appetite to explore. This is far, 7.6 billion. And here is a light curve from the AAVSO again. And you can see it's pretty faint normally, right? It's around 15, 15.5. But right here, late July or late June or 2022, it shot up to magnitude 13. You can see that in a 6-inch from a dark sky site. And I found out about this through the Astronomer's Telegram. So you'll see some of these really active blazars and quasars. If they have some exceptional outburst, it'll be posted. My personal distance record is PG 1634-706. And it's not even that faint. 11.5 billion light years away. But if you include the expansion, really get to bring those numbers up, right? 21 billion. So really remote object. You're just peering through all of that time, and you know how enjoyable it is for your imagination to imagine all that time of the universe. Um, I don't know, the vastness of the universe becomes incorporated inside you in a small way. And it is a very fulfilling and satisfying feeling to have that sort of deep connection with nature, even nature that is incredibly remote and very peculiar, like quasars. Doesn't have to be faint, though. Doesn't have to be remote to be very interesting and worth following. Some of you followed Betelgeuse just a few years ago when it suddenly faded. There it is, right there in Orion, right above the belt. We all know Betelgeuse. We're waiting for it to turn supernova. Right now, it's just a beautiful reddish orange star visible during, well, it's out right now, as a matter of fact. Here's another light curve, magnitude on the left, dates on the bottom. We see typical for Betelgeuse, and then, no, here it is, typical. And then watch what happened right there in late 2019. It really dropped. It went from 0.4, dropped almost a whole magnitude. Didn't need any equipment to see it all. So anybody could look at it and report their observations. Very, very enjoyable. And then it recovered gradually, not without a little jumping around. So what happened? That's what's so fascinating. When a star does something you don't quite expect. And what happened, as it turned out, was that there was some enormous, I guess, convective upwelling on the surface of Betelgeuse that blasted out into space, literally part of the star, which then condensed as soot and dust and became this dark cloud that partially blocked and absorbed the light of the supergiant star, causing it to fade. And it's just the thought of being able to see that and picture that happening just through the simple observation of fading and rebrightening. Wonderful way, again, to make that connection with this grandeur of nature, this enormity in which we live. Here's my fanciful view of when it's going to go supernova. There it is. Will it happen tonight? I don't know. I can't see from my window right now. Or will it happen in 1,000 years? Who knows? This is a more recent thing, at least that I found out about. When you do contribute, and this goes back to my initial reason for joining the AAVSO, for getting or for spending a ton of money on that telescope, was contributing and making some small difference. And the AAVSO has now a weekly data usage report. You just sign up for it, and they will send you a list of every variable star that somebody has, where they've used your personal observations as part of their research. And so this is from January. Here's the stars' names. These are the variables, number of observations used. This is a student who used it for an analysis. This is professional astronomer, and so on. So students, PhD candidates, professional astronomers are really using that data to help understand and predict the behavior of these stars. So in the end, that also just contributes to our satisfaction and joy as observers to be able to make some small contribution. And Carl Sagan, he's all over Facebook and YouTube. Great. I'm really glad. The more Sagan I see, the better. But I like what he said here. We are on the shore of a cosmic ocean. What we bring to observers to the sky as observers really does or is a way for the cosmos to know itself through us as a filter, as humanity. And so when I'm out there on these nights where you have the beautiful Milky Way, you feel part of it, and you also feel like you're the reason the cosmos understands itself and can appreciate itself, right? And that's what it comes down to, I guess. It's just the appreciation of nature in these nights when you're out. And there's so many ways to do that. And finally, this is my final slide. It shows some resources for you. There's the AAVSO. This is a great one to find out when short period eclipsing binaries are at their brightest. There are some stars you can watch literally go up and down in a couple hours. Really thrilling to see in a telescope. Really good place, Stefan Karge's quasar monitoring. He's got maps of all these quasars, magnitude ranges, so you can go and sift through there and find a subset that would work for you. David Bishop's, here's the Telegram. Here's another Telegram type free service called the Transient Name Server, TNS, Astronotes. And of course, the minima of Algol, which has been around forever. Sky and Telescope. You'll find that on the web. And with that, my presentation is over, is finished, and I thank you very much. And if you have any questions, feel free.
I can just speak.
Thank you very much.
Hello, Bob. My name is Bill. On the screen just before the Carl Sagan quote, you had a long list of observations.
Yes.
And the objects, and I believe there was a column that was labeled observations. I assume that means the number of observations.
Yes.
And then there was a date on the left, and it seemed to imply that someone made over 200 observations on a single date of an object. And I can get ambitious sometimes too, but I don't understand exactly what that means.
That's when they were used.
It might be more than one person there, possibly, on that column. I'll call it back so we can take a look at it again.
I think, wasn't that a graph showing when the data was being used, not being recorded?
Let me take a
Or the
look.
number of data points they downloaded.
That one, that screen there.
Can you see it okay? We have
The third item, 215 observations, if I'm reading it
Yeah,
right.
I don't know that those are all my observations, but that may have been, mine was one of 100. I mean, I guess I haven't asked the AAVSO, but I assume that mine is in the 104.
So there were many people who observed the same object on that date, and their observations got
So
total.
that's when somebody requested the data.
That's when they requested it, not on that date. So
That's when somebody downloaded the data.
yeah, these actually, the more I look at this, GW Libra 5, these do look like these could be, yes, I think these are all my observations because these numbers look right, like GW Libra, only 4. That sounds right for what I did. So yeah, this is just a request date.
Okay, thank you.
Does that clear it up? I hope so.
Yes, thank you.
Okay, great. Thank you. I'm glad you got a sharp eye. You're looking close. It's good.
You never get the 215 over extended time.
Yeah, 200, that's certainly doable for me because some things you just continually reobserve, like you can observe certain variables they recommend, like Myra type variables. You don't have to observe them every night, kind of silly to do so. Like every week or two is enough. But when it comes to those dwarf novae, for instance, you can observe those every single night, even at minimum. Some of them have fluctuations caused by changes in the accretion disk and also the orb as they orbit one another. So this is from Liz. Oh, sorry, I missed that. The one I've observed the most, I think it said.
Feel free to come off of it.
The
Hey,
one I've
Bob.
observed. Go
Hey,
ahead.
I was just wondering, what's the variable that you've observed regularly over the longest period of time?
Oh, rarely over the longest
No, regularly.
Oh, regularly.
What's the one that you keep going back to every single time you get your telescope out?
Well, certainly Essa Cygni, that's why I put it in the talk, but that would definitely be way up there. And then I also regularly go back to R core bore, T core bore, especially now in the last couple of years. And one of my other favorites, and I'm going to write about this for Sky and Telescope for next Wednesday for the website, is U Geminorum. So that one's up right now. That one is one that I've been back to regularly.
Yep.
Those are the ones that come to mind right away. They're just, you get so familiar with some, you know exactly
Hmm.
where to go. You've memorized the star field, so it's so easy to get.
Yeah.
Are you a variable star observer?
Yes.
Oh,
Yes.
what
But
are your,
just
what are,
recently,
oh,
uh,
wonderful.
well, I'm still trying to figure out what my favorite is. So I keep going around and popping around, and Jeff will probably laugh because he knows this is typical Liz to just kind of bounce around all these things. At some point, I will have my group of favorites, and I'm thinking at some point, one of them will do something that surprises me as opposed to me just taking images. I do imaging. I don't do the visual.
Visuals, yeah. Do you do magnitudes from imaging?
Yes, I'll do the photometry and yep.
Photometry. Wonderful. That's really great. Yeah, it takes a little time to find your favorites. Another one for me is Camelopardalis, Z Cam.
Uh-huh. Uh-huh. That's
Any,
supposed to be kind of a crazy one, isn't it?
it's a great, yeah, that's what's so great about variables is you can go for the crazy ones if that's what you really want. Or you can go for the Myras, that have a nice cycle,
Yes,
pretty
very
predictable.
predictable.
Yeah.
Yeah. Yep.
Yeah, it's like a selection of human personalities.
Yes.
I have a question for Bob. Um, Bob, this is Bill Dillon, and
Hi,
when a
Bill.
dwarf nova goes into outburst, is it the is it on the surface of the dwarf nova, where it's having a mini detonation on the surface from the accumulated material, or is it the entire disk that's brightening up? Do we have a good idea of what is actually where's the brightness coming from?
Yeah, that's such a fantastic question. And actually, I've seen both explanations that it's in the transfer of material down to the surface of the dwarf. Also, changes in what they call the viscosity of the disk, as material, the amount of material is changing from the host star being pulled around and wrapped. So I've heard both. And the reason your question is so great is because I wanted to clarify if there was one was a stronger candidate or more likely than the other. So I've been trying to get a hold of someone I know at the AAVSO to help clarify that question and answer. And I've not been able to get a hold of her. So I have read both are responsible, but primarily from the literature, it's primarily changes within the disk itself and the flow of material in the disk. And when you see an outburst, that disk is brightening. So that seems to be the principal reason. But I have heard that the transfer can also cause brightening.
Walt Cooney may be able to help you with that.
Who is that?
Walt Cooney.
Oh, is Walt here?
He's a member of our club, but he's also he's over the CV section,
Okay.
the AAVSO CV section. So
Yeah,
I will
there's
put
a, oh, go
I'll put
ahead.
his name in the chat.
All right. Yeah, the person I normally speak with, she's really a great, you just call the AAVSO, her name is Elizabeth Wagen, and she's
Yes.
very happy to answer those questions.
Yeah.
But she just hasn't been in lately, so
Oh,
I can't give a definitive, 50-50, 75-25. Hard to
Yeah.
know. So a very perceptive question.
Yep.
Years ago, we used to be able to sign up to get a text message when a GRB happened. Is there a way to sign up to get an email when T4 War finally goes? Or
There are a couple of places where you can to get an email when it goes.
well, a text message or would even be better because I haven't seemed to be keeping up with my emails very well these days.
There is for sure there is for AAVSO members. There's a way to be alerted to it. But just right now, if anytime you want to know, there are at least two websites where you can check. Maybe you're already familiar. You can go to Space Weather, and they have a monitor right there that's telling you
Okay.
T-Core bore. And then the other place is Sky and Telescope now on their webpage has a little monitor that tells you about T-Core bore. But to my knowledge, the AAVSO, there's a procedure there where they will send you a contact information about it. And I think I'm on that list. So
Oh,
are you a
okay.
member of the AAVSO?
No,
Yeah, but it,
I used to take images for Bill Dillon and leave them on his doorstep in the middle of the night, and then he would process them.
oh, wow. Okay. Yeah.
So I
I
was an
did.
AAVSO gopher.
We're all gophers with that. I feel like I'm a gopher too. No, that's, but yeah, those are two, it's constantly being monitored on those two sites. You'll see it in the upper right corner or both of them. So you can check that routinely. I am guessing this, that when it happens, if you belong to any groups, any astronomy groups at all, any mail lists and such, you're going to find out about it right away, through your email list because it's just so highly anticipated.
Yeah, but you're assuming that I'm reading my email well.
Yeah.
Which is-
You want me to send you an email if I hear about it? Give me your email.
So gopher, yeah.
Don't worry, we'll text.
Somebody please text me when it happens.
So,
Yeah, I think we're all, because what I've read, and maybe you have too, that when the star does go into outbursts, that the actual brightness, the second magnitude, the
Wow.
potential is only going to last a day or two, and then it's a
Right.
quick drop within a week right
Yeah.
back down. So it's
Oh,
gonna
so then we can just about be certain it'll be cloudy here in those 2 days.
yeah, that's always
I got money on that.
yeah. I know how it is. We have the same philosophy here in Duluth.
well, I'm surprised that we have a prediction that's like March 27th. Given that the predictions for September, a lot of the popular press had picked this up, see this once in a lifetime thing in September, no October, no November. Well, definitely in 2025, or maybe 2026. And now we've got someone saying March 27th.
Yeah, but if they're right, like it's a good, yeah, well then, they'll be.
Yeah, that
Well,
would be
can you
very
imagine
impressive, but
if they're
given the
right?
track record so far, I think a lot of people are really jumpy about the star, and it's frightened a little bit, or now we're seeing emission lines, and that means the shock wave is coming through, and then nothing.
Yeah, I think that there's been some
Yeah, maybe there is a betting pool for it.
The 27th, it's our next AOW, maybe we're there.
That's right.
Oh, they're hedging their bet because they're not telling you what time in the evening it
yeah, there's been some misinterpretation of the increase in the amount of material coming within the disk that does happen kind of cyclically, so it doesn't necessarily mean that an outburst is in the offing. And if you read that paper, I don't know how many of you took a shot of that link, but if you read that paper, I'll find the link and I'll put it in the chat here too. You'll see that this person has put March 27th, and then there's several other dates that are based upon the orbital period of the star. And so that's the first date, and then there's one coming up later this year, and then there's one in 2026. So you can see they're hedging their bets.
Covering their bets, yeah.
Yeah. It's a star, and that's the beauty of it. They just keep us on edge. I mean, it drives you crazy sometimes, but it keeps it interesting. I always that's why I tell people, just take your cell phone, take a picture. With my classes, hold it up, and if you see it bright, you email. I say, send me an email, let me know. But
When I was a student at Stanford, all the geologists were wearing beepers in the late 1980s because they had predicted this major earthquake would happen in California. It's what they call the Park Field Prediction Experiment. And the earthquake finally happened in 2006.
oh, what? Yeah.
When had they predicted it? Back in the
They
80s?
predicted it for like 1987.
That's the beauty of nature. You heard, who's familiar in the group with Leslie Peltier? Anybody there?
Yes.
So you're probably familiar then with his story about T-Core Bohr. He observed it repeatedly because it had another earlier outburst, right? Before 1946. He observed it every single night. And then one night, of course, he was sick and he was in bed. He felt sorry for himself and he decided I better get some sleep. And it was honestly, it was that night that the stuff went into outburst. He said after that, that was the end of my friendship with T-Core board. He was done. He had put in the time. So it's a great book. If you can find it, there's probably some way to get a easy copy. So.
Well, back in the 1980s, they used to have a visual nova search. I don't know if you remember, but someone had divided the Milky Way up into these 5 by 5 degree squares, and you could be assigned a square to look for your nova. So you would do your own little mini constellations in there. So I had one in Cassiopeia, and I observed it as much as I could when I was in high school and maybe a little bit in college, and then things happened. I dropped it, and then about 10 years later, Nova went off in Cassiopeia. And I looked at binoculars. I thought, gosh, that field looks really familiar. It was my old Nova search area.
Oh my gosh.
Well, if I had kept it up for 20 years, I might have been able to call it. But then I thought, what if I been asleep or sick or something, and then some guy in Japan finds it first, and I've been, looking at that area for 20 years. How did I miss it?
Oh, that is so frustrating. Oh my gosh.
Unfortunately, I didn't feel bad because I had stopped observing it 10 years before, but it was amazing that thing had gone off in my old Nova search area.
I really like that idea though of dividing the sky up, the Milky Way area, especially into 5 degree squares. That's totally manageable, and you could do it. Just take a picture of it every night too. That's your square, and
well, maybe we could start something again.
Yeah, start it up again. It's a great idea. Man.
Well, Bob, I want to thank you for a great presentation.
Yeah.
And your passion for what you do really comes through in your presentation. I mean, very, very interesting. What you've observed and seen and everything inspires all of us. So we want to thank you very much.
Good job.
That's kind of you. Thank you very much. Thank you.